In a study of the accuracy of fast food drive-through orders, Restaurant A had 255 accurate orders and 60 that were not accurate. Okay, so what we want to do here is to construct a 95% confidence interval estimate of the true percentage of all orders that are not accurate. Okay, so that's our estimate. We want to estimate the percentage of orders that are not accurate. So we begin by setting up our confidence interval by obtaining the critical values. So the 95% confidence is what determines the critical value. So I have the normal distribution graph over here. And since it's a confidence interval, we always use a two-tail graph, meaning you could think about if you're 95% confident that you're correct in your estimate, then you're saying there's a 5% chance that you're incorrect. And that 5% chance could be split halfway between the likelihood of an overestimate and the likelihood of an underestimate. So we could say you are 95% confident, so the center 95% of area corresponds to your level of confidence, which means you're saying there is a 2.5% chance of being wrong by overestimating and a 2.5% chance of being wrong due to an underestimate. And so that accounts for all 100% of the area of 1 under the normal distribution. So we need our critical values. So if we want the positive critical value. So what is this right here? Well, our critical value is Z alpha over 2, where alpha is the 5%. So we want the Z-score that separates the upper 2.5%. Well, if we're using Excel, then we have to tell Excel the area to the left of this Z-score. So from this Z-score right here, if we look at all the area to the left, well, there's 95% of the area here, 0.95, and another 2.5% here. So if we look at everything to the left, that's 97.5%. So on Excel, we would say equal norm.s.inv. That's the Excel function for the standard normal distribution. If we want Excel to tell us the Z-score if we know the area to the left of that Z-score. And in this case, it's 0.975 or 97.5%. Okay, so we're going to need this critical value. So over here on the left, I've already set up a table with all the components that we're going to need. So our confidence interval estimate should look like this. The true proportion is somewhere between the sample proportion plus or minus the margin of error. And the margin of error is obtained by taking the critical value, which is Z with the subscript alpha over 2, times the standard error of the proportion, which is the square root of P hat times Q hat. Those are the sample, P hat is the sample proportion and Q hat is the complement of the sample proportion, and divided by N. Okay, so let's see what we have here. Well, there's 255 accurate orders. There's 60 that were not accurate. So together, if we look at the total number of orders, that's 315. So 315 total orders, and of those, we had 255 accurate, and we had 60 that were not accurate. Okay, so we're looking for the proportion or the percentage of orders that were not accurate. So we would say 60 out of 315. 60 out of the 315 were not accurate. Okay, so X is the number of successes, in this case, the not accurate orders. So there's 60 of those. N is the total number of orders, which is the 315, or you could say equal to 55 plus 60. Okay, and there's our 315. And the sample proportion, now remember, this is an important one because that's what we're using in our final answer, basically. The sample proportion would be the 60 out of 315. Okay, so that'll give us the sample proportion. And then the Q, so notation-wise, that's normally given as P hat. So P proportion for the sample, or the symbol would be P hat. And then the Q for the sample, or the complement of that, would be 1 minus the sample proportion. So that would be equal to 1 minus P. 1 minus the sample P, sample proportion. Okay, let me get rid of this for now because we're going to need a little bit more room. The critical value, that's this guy down here. That's our critical value. And you may just know this critical value because 95% confidence is a really common one. And so the critical value we generally use is 1.96. But if you don't know that off the top of your head, we could use Excel equal norm.s.inv. You tell Excel the area to the left of that z-score, 0.975. And we get, about 1.96. Okay, the standard error is this part of the formula. I'm just doing it in piecewise, so I'm not doing too much in any one step. So the standard error is that guy right there. So that's equal to the square root, SQRT, of, and now we've got these three numbers right here, the P hat and the Q hat and the N. That's the B8, B9, and B10. So we could say sample P is right there, times sample Q, which is right there in B10, divided by N, which is the 315. So B9 times B10 divided by B8. And that should give us the standard error. And so if we want the margin of error, that's the whole formula. So that's critical value times the standard error. So this is what we need. We need basically, we need this number here. And we need this number here. We need the sample proportion. That's going to be the center of our interval. And then we need the margin of error. So we're basically taking the sample proportion plus or minus the margin of error. And the margin of error, again, is coming from the critical value. So that's these two right here. The critical value times the standard error. Okay, so margin of error. Margin of error should equal critical value multiplied by the standard error, which is B12. Okay, and that is our margin of error. So lower limit, upper limit. So that's what I'm talking about. Up here. So this is the lower limit of our interval, and this is the upper limit of our interval. Okay, so the lower limit, we take the sample proportion minus the margin of error. And then for the upper limit, we take the sample proportion plus the margin of error. So let's say equal sample proportion minus B13 and then for the upper limit, we take the sample proportion plus the margin of error, B13. Okay, so there's our answer. Let's make this green so it's the final answer. Our 95% confidence interval estimate for the true percentage of all orders that are not accurate, would be between 0.147 and 0.234. Okay, so that's part A. Construct a 95% confidence interval estimate of the percentage of all orders that are not accurate. Part B, compare the results from part A to this 95% confidence interval for the percentage of orders that are not accurate at restaurant B. Okay, so this is a different restaurant. Restaurant B is given 0.173 to 0.263. Okay, so restaurant B was given. So what could you conclude? Well, I mean, what are the options? You could say restaurant A has a higher percentage of orders that are not accurate. Restaurant B has a higher percentage of orders that are not accurate. Or you could say there's no significant difference between the accuracy of the two restaurants. And that's the case in this problem. There's no significant difference because these two confidence intervals overlap each other. All right, so if we look at, let's say we look at the number line. So here's 0, and here's 1. So here would be maybe 0.5. Well, restaurant A in green is from, let's say, 0.147 to 0.234. And restaurant B, which I have in blue, goes from 0.173 to 0.263. So you see, they're overlapping each other. Right? So it doesn't matter that part of the green interval is below the blue interval or part of the blue interval is above the green interval. It doesn't work that way. What this is saying is the true proportion, we're 95% confident the true proportion is somewhere in this range. Well, it could be anywhere. The actual proportion could be here for the green one and here for the blue one. We don't know. So if, basically, long story short, if the two intervals overlap, then there is no significant statistical difference between the two. If, for example, restaurant B, the interval started above 0.234, where the green one ended. So let's say I'm just going to change the numbers for example. If restaurant B started at 0.240 to 255, well, then we would say, yes, there is a significant difference. Because then we get this different scenario. Then we get restaurant A's interval is right here, and then restaurant B's interval is completely above. In that case, we would say, yes, there is a significant statistical difference. But that's not the case. In this problem, restaurant B has a confidence interval that overlaps restaurant A. It looks sort of like this. .263. So no significant difference in accuracy. All right, that about does it for this example. But in general, anytime you're doing a confidence interval estimate for the proportion or percentage, this is how you would approach it. These are on the left, these are the components you're going to need. And this right here, this is our formula for margin of error. In this case, our critical value is 1.96. Anytime you're doing a confidence interval estimate for the proportion, if the confidence level is 95%, critical value will be 1.96. All right, I hope this was helpful.